We will begin shortly, in about 2 minutes. We will begin shortly in just about 2 minutes. All right, good evening, everyone. I've turned the volume down on my microphone to make sure that I'm not overpowering anyone. Give me just a moment. I want to make sure that everyone is still able to hear me, that I'm not recording for no one. So if you'll hold on just a moment. Then I will check it just to make sure. And we will go from there. 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 Otherwise. 1 second. And we will go from there. Otherwise. 1 second. And we will go from there. Otherwise. 1 second. And we will go from there. Otherwise. 1 second. And we will go from there. Otherwise. 1 second. And we will go from there. Otherwise. 1 second. And we will go from there. Otherwise. Sorry about that. Okay, let's move on. I'm hoping that everyone can hear me okay. Let's move on. Remember that during the lecture, if you have any questions or anything that you need to ask me, please look on the syllabus, look online, find my cell phone number, and reach out to me via text. That is where I will answer cell phone or questions. I have my cell phone in hand, ready to go. It is just faster than trying to utilize the YouTube chat. So, let's get started. Chapter 3 in MIS, Business Intelligence Systems. So we are going to learn in this chapter how organizations use business intelligence, how organizations use data warehousing and data marts to acquire data, and what are the 3 techniques for processing business intelligence data, what are the alternatives for publishing business intelligence, or processing business intelligence, and what are the alternatives for publishing business intelligence. Boy, I tell you, I'm tired. Business intelligence. What are the 3 techniques for processing business intelligence? What are the alternatives for publishing business intelligence? Why is artificial intelligence so important? How will artificial intelligence and automation affect organizations? What is the goal of AI? How does AI work? And that's where we're going to stop. We're not going to move on to 2031. So when you look at an organization using business intelligence systems, they're going to include the following: operational databases, social data, purchase data, employee knowledge, and all of that goes into one centralized location of business intelligence application. Okay, all of that analyzed data gets turned into business intelligence that then goes over to the knowledge workers. Okay, so this is a great illustration of that. Okay, the tasks in this grocery store example, the task of informing, deciding, problem solving, and project management. In a grocery store example, which products are selling quickly is an informing decision, or is an informing task. Which customers shop at each location, that's a deciding task. Problem solving task, how can we increase sales? Project management task would be expand to other locations or build in-store cafes. That's a project management task. So these are ways to utilize, or organizations will use business intelligence systems to accomplish these tasks. Okay? Okay? Now, when they're utilizing business intelligence, again, you have to be able to process it, but sometimes, as you'll see, there's feedback results. Okay? It can be a lot like your project management or your software development lifecycle. So they take data sources, they acquire data, they perform an analysis, they publish results, but sometimes they don't have enough data to make a good decision or make a good set of business intelligence for their knowledge workers. So they'll go back to the beginning and they'll keep running that until they say, okay, now give it to the knowledge workers. So that can be a loop of a process until they get to a point where they say, okay, now give it to the knowledge workers. Or they give it to the knowledge workers and they work through it and they say, you know what? We need more. So they push it back to them. See, it's a push-pull location there when they publish results. So, using business intelligence to find candidate parts for 3D printing. So, if an organization uses business intelligence systems and they're wanting to do candidate parts for 3D printing, well, they have to identify parts that might qualify. How do they do that? Well, they go to their vendors and they say, well, you guys make parts that might work for us, so can you make this? And you provide them a design, okay? And or ask them to look at a part that you need and say, can you make a design file and a prototype, right? Or if it is a standard part, you go to a larger customer and it's purchased by them. Okay? You can do frequently ordered parts or order them in smaller quantities. You can use the part weight and price surrogates for simplicity. So these are all ways to gather business intelligence to find candidate parts. Now, here is a representation of that business intelligence system. Okay, so now you see the data all put together. So this data is ready to go to our knowledge workers. So you see your customer name, your sum of revenue, your sum of units, and your average prices. And then, of course, it continues on. Number orders, average order size, unit price, shipping weight, part number, and so on and so forth, right? So let's talk about a data warehouse. Now, a lot of people look at data warehouses, data marts, and how to acquire data, and they think, oh, well, this is big data. No, those are a couple of different things here. Functions of a data warehouse: obtain data, clean it, organize and relate it, and then catalog it. The problem is too many people get those confused. All right, so let's keep going. Here's a representation of that, right? You've got two data warehouses going into a third data warehouse, right? Or database warehouse, data warehouse metadata, all connecting to a data warehouse. Now, on the far left-hand side, you've got your operational database, you've got your other internal data, and you've got your external data. Well, they go into an area where the data is cleaned and prepared for programs, and then it goes into the data warehouse. Cleaned and prepared for programs, and then it goes into the data warehouse. Cleaned and prepared for programs, and then it goes into the data warehouse. And then it goes from there to your business intelligence tools, and it follows the same process as we talked about before. Business intelligence tools, and it follows the same process as we talked about before. The consumer data that can be purchased. Now, this can be purchased from an area when you fill out. If you've ever filled out a questionnaire or one of those. Very sorry. If you've ever filled out one of those cards, thank you, son. I appreciate it. Will you take them out? If you've ever filled out one of those cards, thank you. If you've ever filled out one of those cards that has, like for a survey or for a game, like to win a car or something like that, and you didn't read the fine print, more than likely the fine print says we reserve the right to sell your data. And that's the thing, they get money from those, and you're wondering, how do these competitions afford to give away a car or to, do this all over the country? Well, it's because they're making all the money from selling your data to other companies for marketing purposes. So you've got to look at that fine print. So when they ask you for things like name, address, phone number, age, gender, ethnicity, religion, income, education, voters registration, all of that, you've got to be careful, because more than likely you're putting together an order for data that can be sold to numerous organizations, and it's utilized for marketing purposes. Now, data warehouses, data marts, when they acquire data, again, remember, that data has to be cleaned. So when they get this data, they're going to have data with missing values. It's going to be dirty, inconsistent, and it's not integrated. It's got the wrong granularity. They're going to have data with, or they just flat out have too much. They may not need all of those fields. And so they've got to fix it to make it good for them. Okay? So when they take it, they've got to process it, just like any other situation that we talked about in all these other chapters. So these are your data producers, your data warehouse. Again, you got your metadata and your data database, and then you got your weblog data. Now, your BI tools for web clickstream analysis, turns out web page data feature or design features, right? Then you got your web, that is a web sales data mart, okay? Then you got your store sales data mart, right? Okay, you get your store sales data in there, then your BI tools for store management. So now you have your market-based analysis for sales training. So you see how this works. You see how the data comes in, gets separated out, cleaned, organized, structured, and then it gets put into the right place for all of the things that it can be useful for. Otherwise, it's just bad data. So they've got to find a purpose for it. Okay? So what are these data structures, right? So when you say a data structure or structured data, right, you got your data warehouse, that's structured data. You got a data lake, structured and unstructured in a data lake. Now, I make this illustration in this class every time, and it tends to help people think this through. When you have structured and unstructured data, structured data, think of it like it was created by a computer. Okay, your database, your file structure was organized, created, and populated by a computer system. Okay? So there is no doubt in your mind it would be logically organized. Unstructured data was created, organized, and populated by a human being. You cannot guarantee that it is logically organized. It may be logical to them, but it may not make sense to anybody else. So you got to be careful. Okay? Now, in a data warehouse, data is clean and filtered. In a data lake, it's raw data, which means you can't make decisions off of it. It's just raw. Okay? Data warehouse, operational systems, and purchase data. Well, data lake could be anything, right? You've got everything in there. Look at that list, right? Used by business analysts, that's what's in a data warehouse. And a data lake, it's used by data scientists. Okay? So the difference there, analysts are making decisions based upon clean, structured, organized data that's already been quantified and has calculations available, right? Raw data, they're looking at statistical analysis and variance based on raw structure, right? So something else to think about. Raw data, okay? They're looking at statistical analysis and variance based on raw structure. Business intelligence analysis type. Reporting, data mining, and big data. Right? I'll let you read the rest of those. But those are your three purposes for business analysis. You're going to have some sort of reporting. Why? You're trying to gain information from something. Right? Something happened in your organization and you're trying to figure out why, either positive or negative. If it's positive, you're trying to reproduce it. If it's negative, you're trying to not have it happen again. Data mining. Well, you're trying to pull data to understand where your market research is for a certain population, so on and so forth. Big data. All right, now this is where people get confused. Big data, you got your V's over here. I ain't going to read those characteristics. Your volume, velocity, and variety. Variety. Oh my word, variety. Big data, you got your V's over here. I ain't going to read those. Man, I need sleep. You got your volume, velocity, and variety. Okay? And that is part of your big data. Some applications use reporting and data mining as well. But and in your big data, you find patterns and relationships in big data, right? It is a monstrosity. Okay? You find patterns and relationships in big data, right? It is somebody needs to come take care of me. I think I'm losing my mind. Now, RF&M, recently, frequently, and how much money. These are the things that people need to start looking at, your RF&M score, right? RF&M, recently, frequently, and how much money. R, how recently a customer has ordered. F, how frequently a customer has ordered. And M, how much money the customer has spent. So, RF&M score. Big 7 Sports, 5, 5, and 3. And M, how much money? St. Louis Soccer Club, 1, 5, and 5. So they got an R score of 1, an F score of 5, and an M score of 5. St. Louis Soccer Club, okay? 5 and 5. So the business intelligence can use this to say, well, how recently have they ordered? It's not been very recent. But how frequently has a customer ordered? Well, they've ordered. It's not been very recent. But how frequently a customer has ordered very frequently? Well, they've ordered. Okay. And how much money did the customer spend? They've spent quite a bit of money. So it may not have been very recent, but they do frequently buy from us, and they do spend quite a bit of money. It may not have been so Big 7 Sports, they're a recent customer. They frequently buy from us, and they spend a moderate amount of money. Now, Miami Municipal, they rarely buy from us. They are an okay customer, and they don't spend very much money. Now, Miami Municipal, okay, but Central Colorado, they are just routine, man. 3, 3, and 3. They're a consistent customer. They consistently shop here, and they consistently spend a moderate amount of money. So RF&M is a good report to be able to utilize. Okay, OLAP. Well, so RF&M is a good report when you're looking at this sum of sales totals for all of these individual supermarkets. This is a good thing to have. You got your drink, your food, and your non-consumables, and this is your sales totals for all of those for these supermarkets. and then your grand total at the very end. So you've got this that is being calculated by business intelligence data across what looks like a supermarket chain of stores. You've got this that is being calculated by business intelligence data across. And again, this is broken out into, now they're taking it into the California, Oregon, and Washington for drink and food and non-consumables, so you can see what was bought when and by what store. Excuse me, sold. What was sold, where, and by what store. Okay, so now you can really see the bang for your buck on these. And then it goes even further, state and city. So now you're seeing these reports really pay off. Okay, and then it goes even further, state and city. So in your data mining for your business intelligence data, you've got your statistics and mathematics, your cheap processing power for data storage and large data sets, your sophisticated marketing and finance and other business professionals, your data management technology, and your huge databases, plus your artificial intelligence and machine learning. And all of that is coming in for data mining. So now you got unsupervised data mining. All of that is coming. Okay, does not use priori hypothesis or a model. Okay, is solely used by or solely obtained by data analysis. It's hypothesized model. Okay, and that's used to find or to explain patterns that are found. And a good example of it is cluster analysis. Right. So, supervised data mining. Well, this does use the priori model. Okay, it does predictions such as regression analysis. Okay, so you've got your cell phone weekend minutes, right? So you've got 17.5 times customer age plus 23.7 times the number of months on an account, right? 17.5 times. So that calculation there is months times 17.5 times the customer's age plus 23.7 number of hours in a day that is usable plus or times the number of months on an account. So they've been 6 months on an account, right? Times the number of days that are billable, excuse me, not 23.7. I think it's the days of number of months on an account times the days billable. Customer age plus 21 and the 17.5. What was that? Customer age plus 21 and the anyway, there's an example for you. I have to go back and look that up. Anyway, that's priori model and regression analysis on that example visualization. But I have to go back. Sorry about that. Now, huge volume when you're talking about big or business information, business intelligence data. You got huge volume. Well, huge volume would be a petabyte or larger. So if you think about your hard drives, for those of you that aren't huge geeks like me, you've got, you know, small, which is megabyte, then you've got gigabyte, and then you've got terabyte, then you've got petabyte, okay? So this is like thousands, right? Then you've got rapid velocity, or generated rapidly, and then great variety, or verity if you're going to say it wrong like I do. Then you got structured data, freeform text, log files, graphics, audio, and video. Map phase, Google search log broken into thousands of pieces. So here is a illustration using the map phase from Google search engine. Great way to illustrate. Okay. Now, what is Hadoop? Well, Hadoop is an open source program used by the Apache Foundation. Okay, and it manages thousands of computers. Okay, Apache makes server and database systems. Amazon supports Hadoop as part of its EC3 cloud. Okay, Apache makes server and database systems. Hadoop includes the query language named Pig. Hadoop requires experts to use it. Yes, it does. Hadoop includes the query language named Pig. Hadoop requires experts to use it. Web 2.0 and Hadoop. Interest over time. As you can tell, from 2004 to 2019, it has been not much. Okay, 2004 to 2011, interest peaked between those two times for a bit. It went down, and then it's slowly starting to come back up. Between those two times for a bit. It went down, and then it's slowly, and then you got publishing of business intelligence and alternatives for that. Web server, SharePoint, BI servers, these are all alert RSS flows, same thing like you would have RSS flows for news and media. Web server, SharePoint, BI servers, these are all, and there's the skill level needed for all of those as well. RSS flows for news and media. So here's a pictorial representation of what we've been talking about so far, and your business intelligence data source all the way to your business intelligence users and how the devices are getting them there. So far, and your business now let's talk about knowledge management. So your intellectual capital shares the knowledge of those who need that capital. It improves the process quality and increases team strength. Shares the knowledge. So your knowledge management's actually talking about the intelligence of your people. It increases team strength, right? And enables employees to use organizations' collective knowledge. So this is talking about the brains of the people that you got employed for you. Right? Employees are reluctant to exhibit their ignorance. That's true. They don't want to risk showing incompetence. Okay, because it causes competition. Right? And because they don't want it to risk the possibility of them losing their job. Because it causes competition. They're ready for that. Strong management endorsement, positive feedback. Because they don't want it to risk the possibility of them. There's nothing wrong with praise or cash, especially cash. But there's also nothing wrong with telling somebody not knowing something is not a bad thing. It just means that we need to train, especially cash. But there's also nothing wrong with telling somebody not knowing something. Content management systems, support management and delivery of documents and or other expressions of employee knowledge. Systems, support challenges. Management and deliver. These are huge databases when you start getting into large organizations. Okay. The content can be quite dynamic, depending on what all people will list as their knowledge. People have changed careers a few times, and they've acquired quite the vast experience of knowledge. It can get quite varied. Documents refer to one another, so you may have groups of people that share the same knowledge. So your reference material may start becoming quite lengthy. Content can become perishable. Well, what does that mean? If people have certifications that expire and they don't renew them, if they have knowledge in certain technology that doesn't stay current and no longer is available, that's perishable. If they have knowledge, it may also need to be in many languages if you're an international organization, or and no longer is available, if it's perishable. It's actually in multiple languages. Or artificial intelligence. The ability of the machine to simulate human abilities. We're seeing that more and more, aren't we? Could be used in robots, drones, agricultural systems, military platforms, surgical systems, smart devices. Could be used in robots. But why is it important? Agricultural systems, military platforms. It can assist with rapid processing of data. Why is it important? Well, it can assist with rapid processing. We know that there are numerous companies currently utilizing artificial intelligence, and they've started putting out AI assistants. Most of us have them on our phones. Some of them have them in their homes. We depend on them daily. Most of us have them on our phones. Some of them have them in their homes. And how will it affect organizations? Well, here is employee cost per hour in the U.S. on the average. Okay. Mind you, the book was published in 2022, so it's a couple of years old. On the average. So you can take a look at this and see that your cost per hour, and of course that little blue section that's exploded out into overtime, personal time, unemployment, disability, shift differential, life insurance, federal unemployment insurance, workers' comp, Medicare, and sick time. But those are all your costs per hour in the United States. I'll give you an illustration of what it's going to cost, or the potential cost savings. But a lot of people in the 80s said that the introduction of computers into the workforce would allow you to reduce your staff by one person per computer, and it ended up requiring 2 people per computer because now they were twice as efficient, and they needed more people to continue working as efficiently. And they needed don't know how it's going to turn people to continue working as we will see. Sorry about my dogs. Employee fraud, frequency, and median loss. There are percentages of loss and fraud. And the claim here is that with automation and artificial intelligence that you will see a drastic drop in all of these. And the claim here is that with automation and artificial intelligence that you will see a drastic drop. How will AI affect you? By 2030, 30 to 40% of work performed routinely, physically, and mental tasks could be taken out of the current workforce. By 2030, workers will be replaced by robots with IQs higher than 90% of the U.S. population. Could be taken out of the current workforce. Unwanted, dirty jobs will be done by AI and automation. Training and retooling of workers for new types of jobs will be done by AI and automation. Training and retooling of workers for new types of jobs. These are good illustrations that I'm going to let you go back and view and understand on your own. We are going to go ahead and move over to chapter 4. Pardon me while I get it pulled up. I'm going to let you go back and view and understand on your own. We are going to go ahead and move over to chapter 4. Pardon me while I get it pulled up. Sorry about that. Went to open the file and I accidentally deleted myself. All right, moving on. Chapter 4, hardware, software, and mobile systems. Went to open the file and I accidentally After we review this chapter, you should be able to hardware, software, and mobile systems. You should be able to look at it and say, well, what do business professionals need to know about computer hardware? How can new hardware affect competitive strategies? What do business professionals need to know about software? Is open source software a viable alternative? And professionals need to know about software. Sorry, is open source software a viable alternative? And what are the differences between native and web applications? Why are mobile systems increasingly important? And what are the challenges of personal mobile devices at work? Why are mobile systems increasingly important? And what are the challenges all right, we're going to skip this eHermes thing and keep on trucking here. Okay. Now, sorry, the eHermes is a fun little story, but it's not pertinent for us. We're just going to keep trucking. Processors and memory. Well, what's the processor? It's a central CPU, central processing unit. It's the brain. Okay, it can be dual or quad. What's the dual processor, quad processor? It can vary in speed, function, and cost. Especially cost. You know, works in conjunction with the memory or RAM, and it reads data and instructions from memory, stores the results and computations in memory. Okay. But think of it like this. Computer hardware consists of electronic components and related gadgetry. that input, processes, and output,
Think of it like this.
and store data according to the instructions encoded in computer programs or software.
Input, processes, and output.
Simply put.
Think of it like this.
Okay?
And store data according to the instructions
So,
encoded in computer programs.
volatile memory contents are lost when the power is off. Non-volatile memory contents survive when the power is off. So, volatile memory is lost. Non-volatile is retained. Okay? That's the best way to think about it.
So, volatile
So
memory.
your non-volatile, hard drive, solid state, thumb drives, optical disk.
Best way to think.
Volatile, that's what's in your cache or your main memory.
Hard drive, solid state,
Okay.
thumb drive,
Uh,
optical disk.
Here's some hardware types and some examples of those hardware types in this pictorial representation. Again, more hardware types. These are going to be your networking types. This is a server farm. It is a collection of typically thousands of servers. It's a good picture of it. This is not thousands, but this is a small set of racks that would normally be in a server farm. Okay?
Not thousands.
Internet of Things.
Small set of
In
racks
December
that
2018,
would
Amazon
normally
reported
be in a
that
server.
it had over 162 million mobile
In December
browser
2018,
shoppers
Amazon reported
and 122 million shoppers on its
it
app.
had
Okay?
over 162 million
So think about that.
browser shoppers.
Internet of Things.
And
Idea
122
and objects are
shoppers
connected
on
to
its
the
app.
internet. These could be smart devices.
Think
These could
about
be
that.
small little
Internet of Things.
devices that
Idea
are
and
processing
objects are connected to the internet.
individual little bits of data.
Smart
I heard of an
devices.
elevator company that was
Small
using
little
Internet of Things devices to be able to track the number of times an elevator went up and down so that they could get a better grasp on how often they needed to maintenance an elevator. So they're smart devices or they're simple devices. You know, just depends. Microsoft is coming up with things like smart buildings. You know, these Internet of Things is revolutionizing multiple different industries, as you can tell from this pictograph right here, or this picture showing you what all it can do. Okay? Now, bits are used for computer data because they are easy to represent electronically. Bits are used to represent electronically. A switch can be open or closed. An open switch is a 0. Closed switch is a 1. O is off, 1 is on. Okay?
An open switch is a 0.
So there's some pictures of how they are represented.
O is off, 1 is on.
Now, all computer data is represented by bits. Data can be numbers, characters, currency, amounts, photos, recordings, whatever.
All computer
Okay?
data is represented
All
by
are simply a string of bits. Specifically, for size of main memory, disks, and other computer devices are expressed in bytes. Okay? So here is, like I was talking in the last chapter, the way they go up, 1,000 of 1,000 of 1,000 of 1,000. So when you get all the way up to petabyte, exabyte, zettabyte, okay, and it's expressed in bytes, there's that long number that's actually 1,024 exabytes. It's bytes.
There's that long number that's actually 1,024 exabytes.
Now,
it's
disk capacities specified by amounts of bytes, 5 terabytes. Okay, CPU speeds are expressed in cycles called hertz. So you got a processor for a personal computer is at 4 gigahertz. That's a slow one. A fast PC is 5.0 plus gigahertz. Now, digital reality devices. Reality is the state of things as they actually exist. This is reality, or at least, gosh, I hope it is.
Digital reality devices. Reality is the
Different
state
levels of digital reality on a continuum from a completely real environment to a completely virtual reality.
Different levels of digital reality.
Okay, you got augmented reality, mixed reality, and virtual reality. So those are things that are very, very cool, very, very fun to play with. But I remember when I was in high school and they started talking about augmented and virtual reality headsets, and those were just becoming a thing that no one could afford. But they were talking about people spending too much time in virtual reality in their brains getting stuck there. A lot of great movies in sci-fi, but I don't, never heard of it being actually real. So, here's great examples of the different types of virtual environments and the different devices utilized to be able to obtain. Here's great examples of the different types of autonomous vehicles. Kind of a hot button topic in the United States right now. So, make things easier, cheaper, and faster, and safer. Not faster, safer. I don't know about cheaper, but automobile accidents may become a thing of the past. Car insurance eliminated. We'll see. And it will eliminate the need to have multiple cars. Eliminate the need to have multiple cars? I don't think so. Avoid costly traffic tickets, parking tickets, and DUI citations. Eliminate the need to have multiple cars? I don't think so. Well, we'll see about all that. They'll still be controlled by humans at some point. They'll want to be able to drive themselves. Auto sales. Well, we'll see about all that. Auto loans, insurance, all this is supposedly going to go away, but they're pitching this whole idea. How will self-driving cars disrupt your personal life? Eliminate pizza delivery jobs, truck drivers? Well, for one thing, they'll want to take my hot rod, and I don't think that's going to happen. Eliminate pizza delivery jobs, truck drivers? The other type of autonomous vehicle that will transform business is a drone. Remotely controlled aircraft. It's estimated that a drone package delivery market will be worth $91 billion by 2030. Jeff Bezos, going to be a ridiculous amount of money that he's going to be making. All started because he wanted to sell books online. Robots are machines that are programmed to sense the environment, make decisions, and perform tasks automatically. Robots will transform businesses because they will automate much of the physical work currently being done by humans. Industrial robots or robots used in the manufacturing process. 3D printing. Well, we see that it's being done in plastic, metal, ceramics, food, biological material. I even saw cement 3D printing the other day. That was impressive. Somebody's building cement houses out of a 3D, turned a cement truck into a 3D printer the other day. That was impressive. So, what happens when 3D printers of extra large objects like cars, airplanes, boats, houses, drones, etc. become possible? It is possible. I've seen it happen. Cryptocurrency. This one's always fun to discuss. Businesses are using blockchain, a decentralized public ledgering system used to record cryptocurrency transactions to manage transactions in the traditional sectors like shipping, real estate, voting, and stock trading. Let's just move on with that one. I have too many opinions. You need to know about the functions of operating systems, servers, and applications. What are your choices? Which do you choose? Do you want a thin client or a thick client application? Native applications are programs that are written to use a particular operating system. They are sometimes called thick clients or thick client applications. Web applications, thin client applications, run within a browser and can run on any type of computer. Okay? Some versions of Windows resides on more than 85% of the world's desktops for business users, and it's more than 95%. More than 85% of the world's desktops for business users, and it's more than 95%. Yeah, this will tell you it's still published in 2022. Windows 8 and now 10, now 11, are distinguished by modern style applications that are touchscreen oriented and provide context sensitive pop-up menus used with a mouse and keyboard. Virtualization process by which one computer hosts the appearance of many computers. One operating system called the host operating system runs one or more operating systems as an application. Host operating system the host operating system is called a virtual machine. Right? Each virtual machine has disk space and other resources allocated to it. Operates as if it is installed on
its own
virtual
computer.
machine has disk space
The host
and other resources
operates. The host operating system controls activities of virtual machines to prevent them from interfering with one another.
The host operating system controls activities of virtual machines.
So this is a figure of a Windows server.
Interfering with
Okay.
one another.
Own versus license. So this is a new item here. Used to you could buy the license. Okay. Now you're having to technically lease it and pay for it every year. It's becoming a different market. They're finding a different way to get
Now you're having to technically
more money out of you.
pay for it every year.
Okay. Horizontal market application softwares provide capabilities common across the organization and industries. Word processors, graphics programs, spreadsheets, and presentation programs. These are all horizontal market applications. Then you got your vertical market applications softwares. They serve the needs of specific industries. There's examples of these programs that are used by like dental offices, and they schedule appointments, they bill the patients. Then you got your one-of-a-kind applications, right? They're developed for a specific need. So they'll be very unique in how they're developed. So
they're developed for a specific need.
but because of risk and expense in custom developments is the last choice alternative used only when there is no other option. So one-of-a-kind application
is the last choice alternative.
going to be your last choice, right?
Used only
Firmware. Well, when you have a piece of hardware and there's a security vulnerability, or there is a better way, more efficient way for that piece of hardware to operate, then there is a firmware release for that system put out.
There is a better way, more efficient way.
Open source. Here's some examples of it.
Then there is a
Okay.
firmware release.
Open source is software that is
Open source.
written, maintained, and put together by a conglomerate of users on the internet, and it is not private. It's open.
By
Okay.
a conglomerate of users.
Most companies
and it is not
that have security and privacy requirements will not use open source because
that have
they can't trust where it came from.
and privacy requirements will not use open source because
So why do programmers volunteer their services to open source projects? Well, they claim it exercises creativity, freedom to choose objects or projects, exhibit skill to their job, start business selling services, and succeeds because of collaboration. That's what they claim. The problem is, it also leaves the door open for vulnerability for security and possible hacking, because
it also is
you leave the door open for other people to get in there and change your code. If you do not have good bulldogs watching the door, that's why I don't allow open source on any of the projects that I do. Here's an example of open source viable software as a viable alternative.
Open source on any of the projects that I do.
I disagree. It's not a viable alternative. It's a last choice option only if you have no other choice, and even then,
I disagree.
no.
It's not a viable alternative.
Developing native applications. These are languages and are object-oriented, which means they can be used to create difficult, complex applications, and if used properly, will result in high-performance code.
Which means they can be used to create difficult.
The benefit of such languages is that they give programmers close control over the assets and computing device and enable the creation of sophisticated and complex user interfaces.
They give programmers close control over the
Choice depends on strategy, particular goal, schedule, budget, tolerance for managing technical projects, revenue, and other factors. In general, thin client applications are cheaper to develop and maintain, but they do lack the wow factor.
revenue and other factors. In general,
The major elements in a mobile system, they're users in motion, mobile devices, wireless connectivity, and cloud-based resources.
the major elements in a mobile system, they're users in motion, mobile devices, wireless connectivity, and cloud-based resources. The major elements in a mobile system.
And ladies and gentlemen, that is chapter 4.
Mobile devices, wireless connectivity, and
Please remember that if you have any questions, please reach out to me.
that is chapter 4.
Other than that, I will be grading
today and tomorrow to put
questions, please
out
reach out to me.
grades for your first week's assignments.
Grading today and tomorrow to put
Y'all have a great evening.